it is given that we have some sort of mass spring damper system, also known as a mechanical translational system, arranged like this. And if you look at the physical system itself, the basic idea over here that oh, sorry, we should know that the system input and output can be analyzed or can be identified based on the notation in the physical system itself. So now here, if you look at the one that I showed here, U is considered our input, the force pulling these two masses, and the output or the states that we would like to consider here, or um, to be is the output lah. The output is Y1 and also Y2, the displacement of mass 1 and also mass 2. So here, the strategy of constructing the state space model uh, can be seen based on the solution that are provided over here. However, if you look at the solution, the differential equation is already given. So it's you have to if in real situation or in assessment situation, this differential equation will be not being given. So you need to come up with your analysis, or your you need to determine, examine the differential equation by yourself. So the best way to do it is by looking at the system and start doing it based on the free body diagram. If you look at one of the material that I provided earlier in e-learning, I've give you some of not some like another approach on how I'm gonna do or how I'm gonna come up with the state space model based on my approach lah. Um, Not only my approach, it's like actually, if you try to come up with a state space model, the first thing that you need to know is that you need to come up with a free body diagram in order for you to get the differential equation. So some of the technique or some of the approach that maybe one will use is that based on the solution that provided in this example, maybe the way he or she analyze until he get the state space model is by defining some of the state variables over here. So you can also have a look at my approach, where my approach is a bit a shortcut compared to what you've seen in the lecture notes, because since I have two mass over here, so in mind that this is I should come up with two differential equation based or based on the mass 1 and also mass 2. So from there, the differential equation itself is a second order differential equation, meaning that the first or each of the differential equation, second order differential equation, must have two states. The first one is the derivative of the displacement, or y1 dot, and another one is y1. Same goes to another mass, since we have a two or second order differential equation, meaning that I will also have two states over here. So in total, since we have two second order differential equation, in total we should have 4 states. But actually we only need 2 states considered as our output, which is the displacement of mass number 1, i.e. y1, and also the displacement of m2, which is y2. Okay, so the way I did this is by first draw the free body diagram and assess what is the force acting to that particular mass. One thing that you need to really understand or really remember that once you have come up with the force acting at the mass, you need to assume or you need to select which direction is the positive direction of force. So the selection of um, direction of the force is by looking at the um, direction of the displacement as well as the direction of the force acting towards the system. So in this case, we believe or I assume that um, not assume lah. I select I select the right hand pointing towards right hand side is considered as my positive action of force. So from there, um, from the second Newton law or Newton method, second law of Newton method, if I'm not mistaken, and we come out with we can determine what is the differential equation from the definition of F equals to ma. F here is sum of the forces. M is the mass value, and A is the acceleration of the displacement. Okay, you can get you. I think you should go through this solution and maybe you should compare it with what we have over here. In general, if you look at the solution and um, it, my solution and the solution that provided in the lecture slide, the the signage over here should be the same should be the same. However, the arrangement of which row should it be depends on the definition that you define over here. If you look at what we have in the solution, x1, okay, consider this is x1, x2, x3, x4. X1 over here is considered as y1 and x2 is y2. However, in my solution, my x1 is y1 dot, my x2 is y1. So it's like in an opposite sort of, it shuffle itself. So that's why you see over here my first row have this all these element. However, in the solution in the lecture notes, all the elements appears in the second row. And the position over here also shuffle from each other because I define my x1 as y1 dot. However, if you multiply y1 dot and negative b over m1, it will be the same as um, provided by the solution. If you see here, x2 is y1 dot must be multiplied with negative b m over m1. So the arrangement might be different, but if you uh, multiply that and come up with the differential equation, and it should be the same for both. All right, that's for example number 1. Okay, this is our main content for today, which is how do we convert from state space representation into a transfer function. Maybe I'll skip this one. Okay, to do that, the easiest way is by using MATLAB lah, of course. And you know that if you have a transfer function you can also easily convert it into a state space model. So the way we did that is by first in MATLAB code we need to define what is the numerator, the denominator, and then we should use this code where system transfer function equal, this is not necessarily the same, um, it's defined by you actually, but this one tf and then bracket num den. Okay, this is basically what we did over here. We try to convert from transfer function into a state space model. So once you finish with this line, you will end up with this transfer function. Okay, and then when you try to convert from transfer function to a state space, you must use this SS system transfer function, or what you define over here. So SS this TF will give you all these answers. Okay, it's very easy to use MATLAB. And of course, if you have this the state space model, you can also come up with the block diagram. I will skip this part. What I need you to do is you need to go through how to come up with this block diagram. Okay. Right. Since we can easily convert from transfer function into state space, okay, we can also convert from state space into transfer function. And of course, to do that, the easiest way is by using MATLAB from the system state space model into transfer function. It's easier by using MATLAB, of course. However, in theory and in manual calculation, how do we convert from state space to transfer function? So this is the idea or the steps that we try to consider. So first, we have the model itself with two states equation as well as output equation. We have matrices A, B, C, and D. And then we should take the Laplace transform, assuming a zero initial condition, meaning that we neglect all the initial condition of our system, and start solving the equation 3.69, okay, give us this solution. And we do some substitution and so on, and towards the end, to convert from transfer function, to convert from state space into transfer function, what you need to consider is you need to consider setting up this equation. So this is the most important thing to consider when you try to convert from state space transfer function. It's very easy. This one, maybe if you want to know the basic of how this equation come about, maybe you should go through this equation. But however, for this course, the main objective is what is the transfer function if given a state space model. So you need to know this equation, how to use this equation. So if you go through this equation, you see that we can easily convert this state space this state space model, okay, into a transfer function just by solving this equation. So we know that the metric A, B, C, D is given by the state space model. Ooh, wow. Okay, the matrices is given by the state space model, and using the matrices over here, solving this equation, you should get your transfer function. And please remember that in this equation, it involves inverse matrix. Okay, so you need to really particular or really know how to solve the inverse matrix as well. Okay. Right, now we get into the example. Okay, let's say we have this kind of system, and this system, we also have analyzed what is the state space model for this mass spring damper system, and we end up with this state space model given by x dot ax plus du, y equal to cx plus du, and this is the all the information of the matrices of the system. All right, how can we utilize this information, okay, in order for us to convert it into a transfer function? Okay. So here, how we did that. So first of all, you need to know that you need this equation. You need to know that to convert from state space model into a transfer function, you need this equation. And the rest, I think, is on how do you multiply, how do you solve this equation? Multiply maybe by using some of the, what do you call it, some of the definition of matrix transformation from normal matrix into an inverse matrix and so on. Okay, what I would like to highlight over here is that maybe you don't know what is this SI. Okay, I here is the identity matrix. Okay, if we have 2 by 2, okay, if you have a 2 by 2 A matrix, meaning that you should have also a 2 by 2 identity matrix, which is I here is 1 1 0 0, a diagonal matrix, or some people say this is identity matrix. And with this identity matrix multiplied with S, meaning that if we multiply with S over here as operator, it will lead towards S 0 0, a diagonal S matrix, or S operator matrix, Laplace operator matrix. And remember that if this A is 3 by 3, what happens if this A is 3 by 3 matrix? Meaning that this SI also should be a 3 by 3 matrix. And a 3 by 3 matrix is, of course, we have a 3 by 3 identity matrix multiplied with S, and we will end up with a diagonal matrix, looks like this. Oh, another one. Okay, something looks like this. Remember that, yeah? So using this sort of solving the equation, finally you will end up with your answer over here. I need you guys to go through the mathematics, spend some time, have a look at how do we handle the inverse matrix, and how do we handle the S matrix over here. So finally you will end up with your answer of transfer function over here. Okay. And I think that's about it for today's class. Any questions so far?
So far, so good.
Okay, this is not something which is very difficult, but you need to spend some time in order for you to get familiar with what's going on, or how do we solve the equation. You also need a strong um, mathematic background. So the content is not that difficult, but you need a very strong mathematic knowledge lah. All right. Looking at the rest of the slides over here, I have exercise. Here I have my state space model, and what you need to do is you need to convert the state space model into a transfer function. I also provide you the answer. Maybe you can check your answer later on. Um, Another one is this example. Okay, here we have a 3 by 3 matrix. Remember, to handle 3 by 3 matrix, what you need to do, or what you need to consider, is that your S over here, your SI, should also be a 3 by 3 matrix. And I also provide you with the answer over here. And looking at the answer, of course, the highest power of our transfer function, or the denominator side, is to the power of 3, s to the power of 3, or third order differential equation. Since we have three um, 3 by 3 matrix for A. Okay, any questions so far? I actually need you guys to do two things, or not two things, three things. The first one is to go through this example first, and try to finish up, or try to do some exercise on this one. Another one is last time I not skip lah. Actually, I need you guys to, if I explain over here, maybe now you understand, but later on you will forget about it. I would like you to come out or construct this block diagram based on the information that you have over here. The way you, how this block diagram come about. So if you one by one, or if you build it by yourself, based on the answer that I have over here, maybe you should remember that one as well. And the last one is the one that we have in part one. If you look at in part one, we have examples, and also we have exercises. So maybe exercise one is, maybe you can skip this, or make, if you want to do it, maybe you can do it to gain what call it, to be familiar with how to arrange the matrix for state space model. However, the most important thing is that you need to practice free body diagram. How to provide, how to get a state space model based on a physical system. The first one, you need to come up with a free body diagram, and later on get the differential equation, and finally for the state space model. Because this sort of question, or this sort of exercise is very useful for you, in order for you to score good marks in your assessment. So this is very important, especially on the translational mechanical system. Okay, maybe you can also practice this one, and if you have time, you can also do this homework as well. All right, for these exercises, maybe I will Yeah, maybe I don't want to burden you with a lot of work to do. Uh, what I mean is compulsory work to do. Um, I think it's your responsibility to know that you need to do some revision on this matter. So I don't like to put a submission for the exercise available over here. Maybe later on lah. Maybe later on. Maybe on the pole placement control design. Maybe I would put it as a compulsory um, submission for the exercise. But at the moment, I think you should be honest with yourself. If you don't know how to come up with a free body diagram, so this is the time where you should learn on how to convert from physical into a state space model. Given that you need to know how to use how to come up with the free body diagram as well. All right. I think that's all about today in terms of lecture material. Okay, I would like to last time or in Tuesday class, I mentioned about assignment. Okay, this assignment, I think we should do it um, individual. So this is what I have last time. Design control system design via pole placement method, and I think the question would be similar over here. I just replace this one as 2020 2021. Then it's um, available for you lah. So now the 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 preparation be this is not a group work, maybe in individual manner. Um, each of you need to come up with the report of this assignment. Right. The thing that I would like to highlight over here is that, okay, maybe I try to later on repair this one. This is not applicable. I only need you guys to prepare 6 to 5 pages article, but believe me, it's not that easy. You may select any second order system transfer function. Okay. Um, the system transfer function you decide by yourself. Okay. And compare your control design with a conventional PID method, meaning that you have this system, and then you design a controller using a pole placement and compare the performance with PID control method. Or PID, I think it's the easiest way is by using the block diagram available in MATLAB software. So you compare the performance or output performance of both systems. All right. And the thing that you need to be or very particular is the format, because one of the rubrics is the format. Okay, before we get into the rubrics, we go through into this this information. And here I wrote that the report must be in IEEE article format, which consists of the following information. So IEEE article format, IEEE article format, the template can be downloaded from maybe from IEEE website, or maybe if you look at e-learning, I think I've provided the template as well. So you have to use this IEEE article format, and this is the content. and towards the end, you should have references, and maybe this is not um, applicable for you guys. And okay, this is very important about plagiarism. Plagiarism is strictly unacceptable. I will know whether this the content, or not the content lah, the wording, the way you write your assignment, whether it is from you or whether it is from you just copy from other people. So I will check lah this article content, apa ni, Turnitin similarity report. I will check this one. Hopefully there's no it's not involved with plagiarism issue lah. All right, this is sort of call it information for you guys, and on the guidance for you guys, guideline for you guys to come up with the report of assignment. All right, I will show you my previous year's students, what they did. Okay, this is the work of two students, Tim and also Chan Chin Hui. Okay, what they did over here is very, I think, excellent work, because all the, I mean, the guidelines, they follow all the guidelines, as well as they provide some of the thing that most of students didn't provide it. Okay, what I mean over here is that, okay, that the format is the format is okay, based on IEEE format. However, here they have this one. I also surprised. They have this part. This part. Okay, they have the linearization part, where I didn't expect this linearization part. So I only hopefully they will come up with all this transfer function. It's okay, but I did not expect that they get into that particular matter. They don't have to linearize the system, because why they have why they need to linearize the system is because, okay, this is the linearization process. The one that I mentioned just now is the equation of forces of the system. Why they need to linearize their system? Because the system is a highly nonlinear system. So they need to linearize the system before they get into a pole placement, before they can apply pole placement lah. Actually, pole placement also can be applied if your system is non-linear. However, you need to linearize the system first, and later on apply by using pole placement. All right, that thing, I think it's very good work, excellent. I can rate it as excellent work. So the rest, I think you haven't learned yet. Maybe later on we will learn on how to come up with a controller design using pole placement. The one that you know how to do so far is up until this part, up until this transfer function part. Okay, the rest, part B, you not yet. Maybe later on we will learn on how to design a controller using a pole placement. And here are the the what do you call it, the analysis that they provide to me. So at the end, if you look at the conclusion, okay, if you look at the conclusion, maybe it's you should describe back your what is your finding, and the finding is not necessary in this case. In this case, in this assignment, not necessarily a positive finding or a good finding. Meaning that, okay, let's say if you set your where did they set their, okay, let's say here, um, here the criterion of 2% will be used. Okay, the overshoot, the criteria of overshoot, oh, not here, over, am I ending over here, desired performance specification, they need a 10% of overshoot and settling time about 0.5 seconds. If you look at the result they presented to me, the overshoot is 12.79 or 12.8, and settling time 0.3. Here, I would say that this criteria have been met. However, this is not being achieved. And if you have your result, if you cannot achieve your result, it's okay. I uh, I would okay with that. The thing that I would like to have a look is that the steps of getting all this information. So that's the step have that you have done in order to get the desired performance. Here, I would say that the desired performance that they set is not being met. Okay, you should have a percentage of 10% overshoot and also settling time below 0.5 second. And based on the result that they have over here, maybe one is achieved, another one is not achieved. So if you have this kind of result, it's okay. I would accept that one. However, what you need to explain is, if you compare with the one that you have in PID and the one you have in terms of settling time and overshoot, you should be able to compare these two. Maybe you can say why this might be happen, why this is happen, something like that. Here, if you look at the description, is quite comprehensive, and the conclusion, we get back into the conclusion, it's not saying that you should achieve your desired performance. I mean the what do you call that? Um, it's not mean that if you don't achieve your desired performance, meaning that that is wrong. No, no, it's not like that. You, if you don't achieve your desired performance, it's okay, still okay. But you need to know how to explain why uh, it become like that, and also maybe you should also explain on how do we further improve based on what you currently have. So that is more important in my perspective, because of course lah, this is based on one to get this result. Maybe you try to use, you select one, maybe later on you will know, you select one value of whole or one value of gain. Maybe if you tune the controller, the result will be better. So that is the thing that you need to explain on how the way on how to improve your current result. So last time, uh, my student afraid that they said to me that I cannot achieve my desired performance. How, yeah? So I explained to them that it's not about achieving the desired performance. Okay, it's about on how do you make use of the result that you have, and your proposal or your idea on how to achieve that desired performance. That is more important for me. So this is sort of example lah. I will show you another example on student report. Okay, this is coming from Cairo Shazwan and also T1U. Okay, the format, yeah, according to the format, but if you look at the one that they did explain over here, they only use a simple second order system, which is, I think, based on this kind of system, it's still acceptable because um, it's according to the guidelines that I provided earlier. And here the topic is time scale model for body blood glucose level. Okay, what I'm interested is what is the selection of the transfer function itself. And towards the end, they did compare it with PID as well, if I'm not mistaken. Yeah, PID controller. And if you look at um the desired performance, did they mention the desired performance? They didn't mention what is their desired performance over here, but however, they did compare their results of pole placement as well as the PID, so it's okay lah. The point that I want to highlight here is that um, you don't need to have something which is very complex. If you look at Tim and Chan work over there, their system is very complex. They need to linearize the system and later on perform the controller. What I need you to do is you you select one of a system, and from that system you give what is your desired desired performance that you would like to have, and you design a controller using pole placement and compare it with PID. That's enough, I believe. But please lah, if you have a highly nonlinear system, make sure what you need to linearize it first. Okay, you need to linearize the equation, which is this is I believe is very good and excellent work. However, if you have something which is um, something looks like this, okay, presented by Khairul Shazwa and Tiwani, it's also acceptable for me. Okay, and I think the lacking over here is describing the abstract. Okay, describing the abstract is lacking over here because you know that in an IEEE paper or in a manuscript or article, conference or journal, you always need this kind of format. You always need an abstract to describe the whole um, content of your articles. So the format is very crucial, I believe. I think they forgot to write down their abstract and focus on the content, only on the content. All right. That's the example, and maybe I would like to highlight the rubrics. Okay, rubrics, assignment 1 and 2. Okay, here are the rubrics. If you look here, the rubrics, in order for you to achieve marks based on the rubrics, is very easy. If you fulfill all these items, it's easier lah. But it's not that. Um, I think that the easiest points or easiest item to score over here is demonstrate skill applying modern tools. Of course, you will use MATLAB, and if you use MATLAB to analyze your system and also to compare the performance of the controller, of course, here is easy 3 marks over here. And also the number of reference. If you in my guideline, I said that you need to have at least eight. So in the rubrics here, if you have more than seven, meaning that you get full mark over here. It's very easy. And of course, if discussion, you have a comprehensive discussion, easy 5 mark. Uh, don't forget about this discussion lah. If you forget about discussion, and of course you will not get marks in your assignment. And the problem definition is very crucial, or it's very important. You need to have a proper introduction, or not proper lah, just um, the the introduction should uh, be written nicely lah. Don't just copy from other people. If you copy from other people, of course your introduction will be looks nice, but I would know if this one is the work of you or the work of other people. All right. I think that's all for today. If you have any question, I will provide these guidelines later on in e-learning. Maybe if you look at e-learning content next week, you will find this guideline later on. Okay, Lim.
Doctor, is it possible Doctor can